Hi there, everybody. This is lesson 4.6 for geometry. If you could open up your student journal to page 120, you will find a couple examples here that we're going to work through. Once you get your student journal open here, we're going to go through this example number 1. It says graph a polygon with the given vertices and its image after the similarity transformation. So really all it's asking us to do here is to plot these points, then to translate it using this translation, and then take that and dilate it. So it's really not that much different than what we've been doing the last several days. The first thing we've got to do is to plot these 4 points. Now you can do this in your student journal. Since I can't write on here, I'm gonna switch over to another screen. When you plot those points, you should get something that looks like that. Again, you're doing this in your student journal. Now, this translation that we're supposed to do says x minus 5 and y minus 3. That means we're going left 5 and down 3. Left because this one's negative, down because this one's negative. So left 5 and down 3. So each of these points here, we are going to go left 1, 2, 3, 4, 5, and down 1, 2, 3. And that's where that one ends up, right there. And then we're going to go with this one. It's going to go left 5, 1, 2, 3, 4, 5, and down 1, 2, 3. That's where it ends up. This one, same thing. Left 5, down 3. This one, same thing. Left 5 and down 3. So it's going to end up right there. And then when we connect the dots, we get our translated shape. Now we're also supposed to take that translated shape and then dilate it using this rule. Now what this rule means here is that we're going to dilate it with a scale factor of 3. So you see the 3 are there, 3x and 3y. That's all that means, is we're dilating with a scale factor of 3 from the origin. That's another important point to make as well. So this point here, this point right here is 1 away from the origin, 1 to the left. So when we dilate it, it's going to end up 3 times as far away. So it's going to be over here 3 away. This point right here, you got to go over 3 and up 2. We're going to go 3 times as far. We're going to go over 9 and up 1, 2, 3, 4, 5, 6. So that point will end up here. And then if we connect where we said those 2 points would be, we get that line. This point, we got to go over 2 and up 3. But again, we've got to go 3 times as far. I'm going to need to move my graph down a little bit. So again, to get here, we got to go over 2 and up 3, but we're going to go 3 times as far. So 3 times 2 is 6, and 3 times 3 is 9. So we're going to go over 6 and up 9. That's where that point ends up. Now this point here, you just got to go up 2. So again, we're going to go 3 times as far, which is up 6. So that point will end up here. And then if we connect the dots, we've got our translated and then dilated shape. So all you're really doing with these first ones is graphing this, then translating it, then taking that new shape that you've translated, the new shape, not the original one, but the new one, and then dilate it with whatever scale factor it tells you. Let's take a look at another example. So if you turn to page 121, we're going to look at example 4. Now this one is a little different. This one gives you where the starting shape, it's M or LMN here. We know it's the starting one because it doesn't have any primes. We've got to describe a set of transformations, reflections, rotations, dilations, and translations that takes us from this original one to the one with the primes here. Now, you'll notice that they're different sizes. And the only one of those transformations that changes the size is a dilation. So let's start with that. Now, this side right here is 2, and then it ends up being 1 unit long. So to go from 2 units long to 1 unit long, we would have to use a scale factor of 1/2. So let's dilate this thing with a scale factor of 1/2 from the origin. So here I've got our 2 triangles drawn. So this point right here is 4 away from the origin. If we dilate it with a scale factor of 1/2, it'll be half as far away. So we'll end up half of 4 is 2. And this one is 6 away. So half of 6 will be 3. So that will end up right there. Now to get to this point, we've got to go over 6 and up 6. So we're going to go half as far. So we're going to go over 3 and up 3. That point ends up right there. Now we can see that we've got this shape the right size. These two are the right size. We're not done yet because we haven't gotten it over here. Now, before we go on, let's write down what we actually did. So you're going to want to write this on your paper, maybe over here in the margin. We dilate it, so you're going to write dilation. I'll show you. So we're going to write dilation. And the scale factor was 1/2. And we did it from the origin. So that's just a description of the transformation we did to get to this big one to here. But we still have to get it over to here. Now everything's pointing the right direction and it's the right size now. So the next thing we have to do is a translation. So from here, looks like we've got to go left 4 and down 1. Left 4, down 1. So if we translate each of these 3 points, left 4 and down 1, left 4 and down 1, left 4, down 1, we end up on this shape right here. So the next part, so we're going to say translation. And let's describe it using a rule. We're going to say x, y, or let's do it in words. Let's just say right. Right 4, down 1. And there we go. So in order to get this original shape down to this one down here, first you have to dilate it with a scale factor of 1/2 from the origin. That gets you here. Then you've got to translate that 4 right and 1 down. And that is all there is to it. Now go ahead and get started on your assignment. I hope this helps. If you got some questions, let me know when we get back together on Thursday. Bye.